Hey, Nate.
Yes, Sam.
Did you ever think about where new diseases come from?
Are these new diseases, or are they just coming from different species, like pigs and birds?
Right. There's swine flu and bird flu, but what other species might transmit diseases to humans?
And why does it seem like there's more interspecies transmission now than there was before?
I don't know.
Hey,
I got a question about that.
Welcome to another episode of Hey, I Got a Question About That.
I'm Sam.
I'm Nate, and this is a podcast and video series where we talk about all of the research going on here at the Penn State Eberly College of Science.
And today on the pod, we are joined by Nita Bharti. She is the Huck Early Career Professor and an Assistant Professor of Biology in the college. And Nita studies human health and infectious disease.
How does she do that, Sam?
Let's find out. So we are joined here in the studio by Nita Bharti. She is a Huck Early Career Professor in Biology and the Center for Infectious Disease Dynamics here at Penn State. Thanks for joining us, Nita.
Thanks, guys, for having me.
Can you tell us a little bit about your research?
Yeah, so in a nutshell, I would say I work on how human movement and behavior influences infectious diseases and how they spread or how they're managed. So I work on diseases that include things like what we hope to be eliminating or where we're at the end game, so things like measles. And then the other side of that is for diseases that are emerging. So how is human behavior impacting the emergence of new diseases? And across the spectrum, for both things we're trying to eliminate or we're at the end game of, and emergence events, human behavior and human movement, and the links between the human dimension and the environment play a huge role.
And so one of the things you're working on is actually looking in bats, right?
Yeah.
That's a weird organism, it seems like, to be studying this kind of thing. And what type of bats are they?
So these are, they're called flying foxes. They're pteropus bats. They're very large fruit bats. And the particular bats that we're looking at or that are involved in this system that we're working on are only in Australia, and they are black flying foxes.
And so do you get to go to Australia to...
I do, and these bats are very soft.
Soft bats.
They're very furry, yes.
And what disease is it that you're looking at in the bats?
Yeah, so these guys have Hendra virus, and they've probably had it for centuries, and it's been fine. And the reason that we're interested in it now is that it's been spilling over from bats to horses to humans since kind of the mid-90s. That's when it was first identified. And that has only happened in Australia, but a very closely related virus, Nipah virus, has been spilling over from bats to pigs to people in Malaysia, and directly from bats to people in Bangladesh and India. And that has been a cause for huge immediate public health concern.
And so if the bats have carried these viruses for however long, way longer than a few decades, I guess, why is this becoming an issue now?
Yeah, so that's really the question, right? What's changing? And from our perspective, we don't think that there's major changes in the virus or the viruses themselves. What we think is really driving a lot of these changes has to do with the human dimension and the environment, and certainly the human impact on the environment. So deforestation and loss of bat resources and bat habitat is a huge it's massively changed in the past sort of 20 or 30 years, and that has changed a lot of where bats are and what they're interacting with.
How do you track these viruses to know that they're going from bats to horses to humans and not just from bats straight to humans?
Yeah, it's a great question. So with Hendra virus specifically, what we know, I'll tell you what we know and what we don't know. What we know is that it looks like Hendra virus can only go from bats to horses. And horses then amplify the virus, and they can infect a number of other species, including other horses and humans. There haven't been any documented cases of the virus going directly from bats to humans, and that's the kind of thing we'd be really likely to know because it's a very dramatic infection. It's not something that would go undocumented. What we don't know is why horses. So we know that horses are not native to Australia, but we don't understand what makes them special in that they're susceptible to Hendra virus, where it doesn't look like anything else is. Other animals that may be directly exposed to Hendra virus have not been documented as infected from bats.
And do you know sort of the mechanism of how that virus is transferred? Is it through guano or something like that?
Yeah, so what we know is that you can find the virus in the urine of a bat. And so what's likely happening is sort of the large-scale environmental changes that have led to the bats physically overlapping in areas where horses might be. The bats that may be feeding in those trees briefly overnight and urinating on the ground below is probably one of the ways that these horses are getting infected.
It's because the horses are eating the grass or whatever that's growing there.
Yeah, they're either inhaling it or ingesting it. So yeah, they're grazing on the grass, but then they're interacting with the virus and they're either inhaling it or ingesting it, and that's how they're getting infected. We don't know what the dosage has to be, but it probably is low enough that those spatial but non-temporal encounters are leading to spillover events.
What's the disease or what are the symptoms that Hendra virus causes? Like, how important is it to kind of public health?
Yeah, right. So it's an emerging disease. Do we care if it emerges? Why would that matter? So Nipah viruses are respiratory and neurological pathogens, and what we see in horse and human patients is severe respiratory distress and neurological symptoms. And so with horses, we see sort of loss of coordination, and they're generally euthanized because it's quite awful. And with people, so far, I think we have had 7 human cases of Hendra virus. 4 of those have been mortalities. And with Hendra and Nipah viruses, full recovery is not a guarantee. So if there's neurological damage, certainly patients will have long-term neurological deficits in a lot of cases. And in some, I don't know how, I've never personally seen this, but some sort of family members and relatives or acquaintances of patients of survivors will report personality changes with the Nipah virus survivors. I don't know what that looks like, but I think that's fascinating. Mm-hmm. Not really an authority on Nipah virus, but that's crazy.
Do the bats exhibit any symptoms when they're carrying the virus?
Yeah, so the bats are reservoirs for the virus. So when I say they've probably been carrying this virus for centuries, they don't show any symptoms. They're just reservoirs. They are completely unbothered by it.
As you're studying this interaction, what are you hoping to learn, and is it about sort of preventing those spillovers from happening in the future?
Yeah, what we really want to know is really what's the cascade of events that's leading to these spillovers that we've been seeing for the past few decades, but not before that. And as we go through some of these environmental shifts and land use changes, we want to know how we can prevent these cascades from playing out. So there's a lot of different steps along the way that lead to spillover events. So we want to know, what are all those things? Where do we interrupt the process effectively to prevent spillover events? And how do we do that in a way that's actually ecologically restorative? And that's really the trick. How do we return the system to a place of stability rather than pushing it further to a place where we're not seeing spillover events, but we're not in sort of this same, let me say that again. So one could pave all of Australia and eliminate the trees and the bats, and you probably wouldn't have Hendra virus spillovers anymore, right? But that's not really the resolution that we want.
There have been other sort of famous cases of these virus spillovers, like HIV coming from simian IV. Is there sort of general things that you can learn about these kind of events by studying Hendra virus in the bats?
Absolutely. I think that when we see emergence events, viral emergence events, that there are some commonalities underlying these events, and those tend to be some kind of shift, right? We generally think about the host, the pathogen, and the environment as the three things that are linked together when we're looking at infectious diseases. And what we see with a lot of these events is that there will be some environmental shift that allows for spillover. And overwhelmingly, there's a change in the host or the human behavior that really amplifies that, right? So if we were to get spillover events that were completely decoupled from human behavior, we probably wouldn't have a lot of the amplification in the human system that we have. And in this case, I'm considering horses part of the human system because they're domestic horses. And so, I really think that there's a huge human element that drives forward the amplification and the transmission of these viruses once they've jumped species.
So I know that in a lot of your research, you use satellite imagery to sort of track movements of people and things like that. Are you using satellite imagery in this case?
So we are. So satellite imagery is great because it's this large-scale passive surveillance tool. There's a lot of different types of satellite imagery that are collected, but there's a lot of it that's underutilized and that you can actually repurpose to detect things other than what they're initially intended to detect. In this case, we're using satellite imagery extensively to look at the changes in land cover. For years, people have been using satellite imagery to look at deforestation and changes in land use and land cover. In this case, we can use it to go back in time a little bit to look at sort of loss of specific species within forests that we think bats are relying heavily on. So we're using it for that. And then we're also able to use it to really document closely the spatial increase in human populations. So looking at how human distribution has increased and how that directly impacts the loss of forested areas for these bats. And that will give us some insight on where we can restore and where we would like to restore some of this habitat.
So can you tell us a little bit about what this habitat loss looks like, and if you think there's anything that can be done to reverse that trend?
So we know that there's been a lot of deforestation and loss of vegetation in Australia. The rates of forest loss in Australia are amongst the top 11, the bottom 11 in the world in Eastern Australia. So that's really sort of rapidly declining habitat. Not all of it is super particular, or not all of it is directly related to these bats. So these bats prefer certain species over others, as sort of any animal would. So what we want to do and what we're working on is to specifically measure the loss of those species within forests and quantify that, and then strategically restore or replant or protect what's left. The trouble with that is a lot of these vegetation species, a lot of these tree species are somewhat unpredictable in the resources that they provide for bats. It's not that they'll provide, so these bats eat nectar. It's not that they'll bloom and provide nectar every single year. So a lot of the robusticity that's built into the natural system is based on the diversity of the trees that the bats will use. And we've certainly lost some of that. And so restoration efforts will really need to be careful about what we're building back into it. And one of the biggest challenges here is that when you go from replanting these particular eucalypt species to getting anything useful out of the bats for them, it's a 20-year gap before they really start producing this nectar, and these blooming events will happen that these bats can use. So that's a little bit of a challenge. That's a long-term strategic effort, obviously. It's not going to be an immediate effect.
So I imagine these bats have to have a pretty big range in order to find trees that are producing nectar at a given time. Are you able to predict that or control it?
So there's a lot of things that are really unpredictable about this system. And the fact that we don't know when things are going to flower, and where the bats are going to find food means we don't really know where they're going to go next. We can predictably say that they'll go somewhere that there's food. So there's that. We can't predict where they're going to move. I think as far as controlling it, we've sort of done that to our own detriment, right? So by massive deforestation efforts, we've actually sort of controlled where they can be and where they'll go. These guys are actually nomadic by nature, so they're used to being able to cover a lot of distance and fly to fly to sort of distant, large blooming events. And I think what we're finding is that we've robbed them of that a little bit. So they're taking up residence in more sort of human areas, peri-urban or suburban areas where they can snack on things like fruit trees or other subpar substitute foods. And that's sort of where we're seeing them encounter new species. And that's part of the issue with the spillover to horses. So there's, maybe there's fig trees or orange trees or mandarin trees, I guess it would be, that are in horse paddocks and not necessarily these preferred foods, but it's enough that when these bats are sort of in desperate places for finding calories, that they'll start to eat these subpar substitute foods. That then likely limits the amount that they can fly. So they may be getting stuck in these sort of feedback loops of if you start eating poorly, then you can only forage for what's nearby.
So bats are really cool, and obviously this virus is incredibly dangerous, but are you learning things that are sort of more generally applicable to, broader studies of viruses and disease and emerging diseases?
Yeah, definitely. So, these bats are super cool. But also, of course, the patterns that we're seeing with disease emergence and these sort of larger public health and global health events are really important. And what we really want to do is to be able to understand the processes that underlie these observable things. So a lot of things have to happen before we see a spillover event or before we see disease emergence. And by the time we see that, it's too late. So what we really want to be able to do with these kinds of systems and these kinds of studies is to understand all the things that happen before a virus spills over or emerges. And the reason that Australia is a great system for this is because it's really data rich. So we're really able to go into a lot of data archives and information that's been meticulously collected over the past several decades and try to reconstruct some of the things that happen. And that's not always possible when we see sort of the final step of a viral spillover event. But in this case, we're trying to leverage that data-rich system into better understanding what could have happened in other systems or what may be happening right now or in the future that we want to be able to worry about, that we want to be able to get ahead of instead of just reacting to. And that's sort of that's the place where we've been behind. We've been able to react to these events, but we haven't been able to get ahead of them and prevent them. And that's really the idea behind this large-scale project. So I'm working on the Australia side of Hendra virus here, but there's a huge team that I work with that's working on the larger concept of Henipaviruses. And so that includes Nipah virus, which we talked about a little bit earlier. And there's a team studying this system, or the Nipah system in Bangladesh. There's people in Madagascar and Ghana who are all working on different aspects of this group of viruses and what we're seeing about their dynamics in the bats, what we're seeing about the dynamics of spillover, and what we're seeing in the environment and environmental changes in recent history that might be driving some of these really important global health effects that we're seeing.
So I think what kind of humanity usually wants is some sort of magic bullet cure that's going to take care of all these things. But it seems like what you're pointing to is that the changes need to come in human behavior. How do you address those things? Because I think those might be the sort of most difficult changes to make.
Yeah, I definitely agree that human behavior is one of the most difficult things to change. And sort of across scales. How do we change human behavior? Often it's risk-based, right? Communicating risk properly. So I'll say I don't know, but I think that part of the issues here are sort of living in balance with the environment and resource consumption. A lot of the reason that the locations where we're seeing a lot of this environmental damage occur are places that are beautiful because of their natural beauty, right? So they're in demand. The value of the land has increased because of that, but essentially the increased demand and the limited resource is going to get to a point where the reason people want to live there is going to be lost. I don't actually know that as humanity we figured out how to curb that, because there's a huge disparity in the financial resources that you have if you're on the development side versus the restoration or protection side. I don't actually know that there's a really logical or clean way to reconcile that. But there has to be a decrease in the motivation to stop destroying, a decrease in the motivation to destroy natural resources. Just because it's something that we want doesn't mean that it's really what's going to work for the planet.
So what are we learning from these emerging diseases?
I think one of the things that we're learning every time we see a spillover event or emergence event is that things are out of balance. We're looking at unhealthy ecosystems or detrimental interactions between different species or forced interactions. And we're seeing the results of that. We're seeing the symptoms, but not the underlying problem. And in that case, what I mean in this case is I think we're seeing the results of detrimental human behavior and what that does to a larger ecosystem. I think some of the things that we can learn from all of this and learn from disease spillover events is if we're the ones causing the problems, we're also the ones who can prevent the problems. It's not too late to change our behavior, and it's not too late to change the ways that we're negatively impacting the world that sustains us. Climate change is obviously a huge part of it, but so is land use change and deforestation. We can be a lot smarter about the way we occupy places and the resources that we take and what we really need. And I think that this is a lot of these events really should be wake-up calls about what we're doing and versus what we should be doing.
So that was cool.
Yeah, number one, I love those bats.
Yes.
Number two, it's kind of interesting to see how, human expansion is affecting the habitats of these bats, and it's not just affecting the bats, it's affecting the humans, because now we're coming into contact with these things and it gives opportunity for diseases to spread.
Right. So if you want to learn more about Nita's research or any of the research going on here at the Penn State Eberly College of Science, we will have links in the show notes below.
If you haven't already, be sure to check out our previous episodes. You can find us wherever you get podcasts and on YouTube, and leave us a like, subscribe, and comment. Hey, Nate.
Yeah, Sam. Yeah. Welcome to your playing with your computer.
Nita, I don't know what Nita does. So we are joined here in the studio by Nita Bharti. She is she's the Huck. She is a Huck early career professor and assistant professor of biology, and she studies human health and infectious disease.
How does she do it? Let's find out.
Any research that involves those crazy giant bats is worth talking about.
Exactly. Look at him.
I mean, I can't imagine you want a quantitative answer to that. If I could say 7.
Right.
Just say yes.
Perhaps.
Hey, Nate.
Yeah, Sam.
Bats are really cool. Especially big, soft, furry fruit bats.
You should be their PR rep, really.
Bats are just amazing. I love them.
I love bats.